Hey, what is up, guys? Welcome to another episode of CCT. So today we're going to solve another random problem, make it easy so that I don't struggle too much. I've never seen this, never attempted it, and yeah, so wish me luck and hopefully I could solve it. I know it's been a minute since I've posted my last video, but I don't know, it's just been school and life and everything, but I'm going to try to get back on track to do a kind of a weekly schedule, or something like that. Maybe 2 videos a week or something. I don't know. Because I also want to stay fresh on this stuff. Yeah. Okay. So given two strings S and T, determine if they are isomorphic. So what does isomorphic mean? Two strings are isomorphic if the characters in S can be replaced to get T. All occurrences of a character must be replaced with another character while preserving the order of the characters. No two characters may map to the same character, but a character may map to itself. Okay. So it's not like this is a ciphertext where like you move everything over I don't know, like 20 things. Because E to G is E, F, G is 3, and A to D is B, C, D, so that's 4. Or like, I guess it's E to G is 2 and A to D is 3. So it's not like that's how it works. It's like E can map to A and G can map to D. Yeah. So, perhaps what we can do is we can go through this. Well, let's just look at this one. Yeah, okay. We could go through this word, both of these words, and like say, oh, E and yeah. Let's go here. Okay, what color should we use? Let's use a nice purple. Oh, I like that one. Yeah. Okay, so we have egg and add. Okay, so what I was kind of saying is we can have a map that's like from first string, so this is like string 1 to string 2. And it basically goes and says, okay, E, so in our map, so map E, the character E is going to map to A. And then it moves on and says the character G is going to map to D. Oh yeah, and okay, so before we make this mapping here every time, like we're now iterating through this and this. Something we should do up here is like make sure strings are same length. I don't know why I just got rid of the word "the" there. I just thought it would be faster, but it's not really. Okay. So now that we know they're the same length, okay, anyway, as we're going through these and comparing them, we first need to make sure that it's not already in the map. And gosh, I might need to look this up. It's been a minute since I've done this, but it might be, so like what we do is map dot exist or find. I'm going to look this up in a second. Exist or find, I'll just write exist, E. And so if it does exist, then this, the letter that's coordinating here, so that letter better equal the map at E. Because if it exists, that means somewhere previously in the word, E has been mapped to A, so then E still has to map to A here. And if it does, then good. If it doesn't, then we return false. Okay, so that's pretty much the setup of this. Let's get to the board. Okay, so we can first check if s.length does not. Okay, I've been starting to use Python, so I'm like in the Python syntax. I'll keep these videos in C++ though. Python's a good language, but C's my home. Alright, so if it does not equal it, then we should just return false. I mean, there's no point of there's no chance of mapping. Okay, then for int I equals 0, I is less than s dot length I plus plus. It really doesn't matter because they're both the same length at this point. Okay, so one thing that I should do is I should make a map from character to character and call that M. I'm so creative with my names, aren't I? Okay, so yeah, now we have to look up map key exists C++. This should really, is it find? Oh, okay, right. If find does not equal end. Okay, so let's see if m dot find s sub I. So s sub I is the character, and we're seeing if it's there. So if it doesn't equal m dot end, oh yeah, we should probably put parentheses around this find. Oh yeah, it's not, yeah, this is what it should look like. So we're looking for that. So if it, actually, let's start off with if it doesn't exist. So we could write that if it's not already in the map. So if it's not already in the map, that's perfectly fine. So then m at si, so that's like the e over here. The e is going to get a because it obviously didn't already exist because there's nothing before it here. So that is just going to get t sub I. Great. And then else, so here if it is already in the map, then we have to say if, so we're going to say if m, so it's already in the map, so if msi does not equal ti, then we're simply just going to return false on the spot, because somehow that letter got mapped to some letter previously, and now it's being mapped to a different letter, so that's a problem. This is what isomorphic means, like there's a mapping for each letter. Okay, so then if we get through this entire thing without returning false, then we can certainly return true here. Okay, that's good. Let's run the code. Okay, let's try something like eggs with an E and this with a D or something. Cool. Should empty graphs be here? if it's empty, then it's not even going to go through here and it's just going to return true, so that should work. What about if it's just one letter? That should also work, but let's just see. Always good to think of test case or edge cases. Okay. Yep, I'm ready to submit. Okay. That's weird that I would return true there. Okay. So here's what happened. Let's see. So if it equals end, yep, it's gonna equal end here. So A gets mapped to A. Okay. And then okay, I see. And then so okay. And then so like what's happening here? I'll describe the error. So we have like A, B, and A. So it's going to go through, and the map's going to do A gets A, but then it's going to get to B, and it's going to say, oh, B hasn't been mapped to anything, so B is going to get A also, but it's not like checking to make sure those are different. So something that I could do to check this is like already been mapped to vector or something. So I could say like, do I want to make this a vector? No, I probably want to, the order doesn't matter, so we can just make this a set. Let's call it set car. Alright, so this is going to be already mapped to. So this is basically to stop this from A mapping to A and B mapping to A, or like just in general two letters mapping to each other. So when we make our mapping, we have to also check if we've already mapped to how do I look for okay set find element C++. You know I've looked this up like 100 times. Okay, it's find, and then okay, value search for define sets generator. Okay, otherwise it returns set end. Okay, so dot find, we are looking for t sub I. So if that exists already, so if it exists already, I think we want to return false because we've already mapped something to it. So for example, A's already been mapped to, then we should return false. And if not, let's just go along with our business and also do already mapped to dot push. I think it's dot push. Gosh, I really have forgotten some stuff. So set push C++, or is it insert? No, there has to be set C++. Let's just look at all the things we could do here. So Is it insert? Oh yeah. Wait. Yeah, you can just insert an element. Okay. So let's put it here. Okay, so then we definitely, I want to try this. Okay. False. Good, good, good. And I mean, that's basically just testing the same concept as this, but I'll run that anyway. Cool. Okay, right. So already mapped to, we can't map to the same thing twice, so that's how we're doing it. Let's see if this runs now. Cool. Alright, so thanks for watching this video. Hopefully you learned something, and I'll catch you next time. See ya.